So let's begin. So it's our second lecture, and let's try to review the first lecture. I think the ones that were slightly confusing were the types of variables and types of sampling. So let's talk about types of variables. We broadly categorized variables as or data as something that's qualitative or quantitative. Quantitative is something you can put numbers on it, and the numbers do have meaning. Qualitative means you can't put numbers on it, or even if you have a number like a student ID or item number, those actually don't have any meaning usually, but sometimes the item number might give you something else. But anyways, those will be qualitative. And even if it's qualitative, there are two kinds. There's one which is just nominal. You only have just names of things, or sometimes it could be ordinal, which means like your student grades A, B, C, D, E. Those are not numbers, but you can say that A is higher grade than B, and so on and so on. So in that case, that's called qualitative ordinal. And for quantitative values, there are two kinds. One is interval and the other is ratio. And usually, most of the numeric data are ratio. Interval data are, in some cases, usually like dates of something, years of something, or sometimes temperature. These are things where the differences between the values do have meaning, but the ratios don't have any meaning. And that's called quantitative interval. All right, so let's do some exercise. Number one, you're at a party, and let's say there were some boxes of Oreos, and people started handing them out, and some ate a lot. Some people didn't like Oreos. I don't know who that is, but some people didn't eat any. And at the end of the party, you start going to every person and, oh, what just happened? It's back. Okay. Yeah, the connection's a little loose. Sorry about that. Okay, so uh, you count the number of Oreos for each person and you collect that data. Okay. So number of Oreos eaten. What kind of variable is it? First, is it qualitative or quantitative? Quantitative, definitely. It's a number, right? Does the ratio have a meaning? Say I ate 10 Oreos and you ate 5. Does it make sense to say I ate double the Oreos than you? Okay, so what kind of variable is it? Quantitative ratio, okay? So this will be quantitative ratio. Okay, number two. When you go to the meat market, you can ask for the quality of beef. Is this a prime cut or choice or select? And these are not numerical values, so you can't say it's quantitative. It's definitely qualitative. But is this nominal or ordinal? It's ordinal because prime is considered as a more luxurious type than choice, and choice is supposed to be better than select. Okay. All right. Number three, United States college data. If you take all the colleges in the United States and look at the the year that it was founded, right? Is that what kind of variable is it? Is it quantitative or qualitative? It's quantitative. Is it quantitative interval or ratio? Huh? Interval, because if one was founded in year 15 or 1600, and another was founded in year 2000. Does the ratio make sense? Well, it seems to make sense, but then you got to try to ask, what does the zero mean? Well, zero is some value that historians decided to put, right? Uh, so that zero doesn't have any significance. So if you measure from uh, the beginning of the Earth history, like what, some billion years ago, um, then the ratio is totally different, right? So the ratio depends on what you choose the zero to be. So that's why the ratio doesn't make sense for this data, and therefore it will be quantitative interval, right? Okay, now slightly different. It looks very similar, but slightly different. Is what if you look at how old the institution is for each college? Yeah,
Quantitative ratio.
it will be quantitative ratio, right? Because now you can say, oh, this institution is twice as old as this other institution. That makes sense. Okay. Okay. And number 5, brand name of a car. What's that? Right. Qualitative nominal. Very good. So these are the answers. I think that's pretty straightforward, except for the interval ratio thing, but I hope that was easy to understand. All right. Next is the type of sampling. Can you read the small font? I wanted to fit everything into one slide, so over in the back might have some trouble. So let me read the types of sampling. There's the convenience sampling, cluster sampling, systematic sampling, stratified sampling, and simple random sampling. Okay. At a school, the list of everyone's names is shuffled via a software. Then the first 20 are chosen for a survey. What kind of sampling is this? Yes? It is simple random sampling. Very good. Yeah, simple random sampling means any subgroup can be chosen with equal amount of probability, right? So the 20 people could be all boys, or could be all freshmen, or they could all be from the same state. Something like that could happen. There's no limitations to it. As opposed to, say, if you did stratified sampling, that wouldn't happen because you would always pick like half should be female, and like half should be, like 25% should be Frenchmen, and you would put conditions on it, right? But simple random sampling gives you equal probability of any subsets to be chosen. Okay. All right. Number 2. For every 5th person entering the park, we ask their age. What's that? Yes.
Systematic sampling.
It is systematic sampling. You pick every nth number. Okay. So you look at certain people visiting a supermarket, and you want to know their preferences or what kind of meat they want to buy and all that. You choose every 10th or something because it's too much to ask everybody. It's such a hassle. Yeah. So if you put something like every nth person, that means systematic sampling. Okay. Take a poll from the visitors of your website. Convenience sampling. It's convenience sampling means you don't care about the quality of data that you're getting. It's like just get something, okay? And usually convenience sampling is uh, not for the actual use. What people do convenience sampling to get some initial idea of what's happening. So just to get a feeling of what's happening with the data. Then later on, you would use other types of sampling to make your data better, right? Okay. Now, in number 4, in NYC, choose 5 random restaurants and ask everyone entering those restaurants how often they dine out. No, you first choose a restaurant, right? And then you ask everybody. Yes? It's not stratified. It's huh? It's cluster. Yeah, it's cluster. Because you choose a few places and in those places you sample everyone. That's cluster, okay? Yeah. Or you sample a lot of people from that cluster. Now, cluster can be sometimes dangerous if your criteria that you're trying to measure could be related to the cluster that you pick. And in the first lecture, I explained that uh, trying to choose 10 people running on the road in SUNY Maritime College and asking for their height might not be a good idea to find the average height because they might be coming from some specific athletic sports team, like a basketball team, right? However, if we choose this entire classroom and get the average height, this will be a cluster sampling, but it will be a pretty good, it will give us a pretty good idea of the average height of entire maritime students because this choice of cluster has nothing to do with height. There is no height limitations for taking this statistics course, okay? Yeah. Or to teach the class, yeah. All right. And number 5, in a region where 30% are Democrats, 50% are Republicans, and 20% are independents, a politician's popularity is measured by polling 300 Democrats, 500 Republicans, and 200 independents chosen randomly. What type of sampling is this? Stratified. Okay. Yeah. You want to make sure that your sample has the correct proportion of representation as the entire population. Because, if the politician was a Democrat and your choice of survey was somehow handed to mostly Democrats, you might get a totally skewed reporting of that person's popularity, right? So that's why stratified would be very important for this case. All right. So these are the answers. Okay. So hopefully that clarified the distinctions between the sampling methods and also the types of variables. Now today we are going to talk about exploring data with tables and graphs, and I'll also mention some things called quartiles. Okay. A local fire department responded to 70 fires last year. Their turnout time, which by some regulation called NFPA 1710 standards, says that it should not be more than 80 seconds in the 90% percentile. And the data is shown below. Now, when fires happen, the response time is very important, right? You don't want the fire truck to be arriving at the scene like 1 hour later. That's too much, okay? So there are regulations of like how long you should be responding to calls, and once it's confirmed, how long the firemen have uh, in order to prepare to go out, right? So that's like the turnout time. They have to be totally ready for to fight the fire, and then there's also the travel time limitations as well. Okay, so let's say uh, you had 70 fires, and the data is shown like this. Okay, now for this data, there are a lot of things that we can ask, and of course, I think for us the most important question would be: Did this fire department meet the requirement of 90% of responses? For 90% of the responses, the turnout time was 80 seconds or below. Okay, it looks like it's pretty good. I do see something that's above 80, like 80 is okay, but say 95.5, that's not good. 88, that's not good. Yeah, sometimes it's not good. Okay. All right. Now, for any kind of data, uh, the question of what is the middle of the data is quite important. And the first thing that you learn is called the mean or the average. And that's used a lot, especially if you're playing baseball or basketball, all kinds of sports. They like to have the averages, right? It's simply the total divided by the number of values. I don't think there's anyone here who don't know what an average is. And then there's the, and in this class, we will often use the word mean and average interchangeably. Yeah. And then there's the median, which is the value at the middle. So what you want to do is you want to sort the values from smallest to largest. And then you look at the middle value, the value that's exactly at the middle. Now, if there are even number of data, you don't have a data that's right in the middle. You have two data that's near the middle, right? And in that case, you have to take the average of the middle too. Okay. And then there's the mode, which is the value that's repeated the greatest number of times. Note that there can be more than one modes. If you have like one value repeated 3 times and there's another value repeated 3 times and 3 is the maximum repeats, you can have more than one mode in that case. All right. So here's a question. What are the mean, median, and mode of the fire department times? And for this, I will try to use Excel. I have the data here. All right. Okay, so this is the data of the response times. Let's just paste it here. Okay, since it's a bit hard to see, let me zoom in. Maybe I can just do. No, that's not. Okay, all right. Okay, so these are the values. Now, to get the average, you simply use the average function, but just to make sure that we're doing it right, 70 is the number of data, right? So n is equal to 70 for this data. And what we want to do is we want to add it first. So adding all the numbers here gives you 4,918.6. And what we want to do is we want to take it and divide it by the number of data, which is 70, number of data points. So if you divide, you get 70.3, around 70.3. So we see that the average is 70.3 seconds, which is below the 80, so it's good. All right. I'm going to delete this because, oh, by the way, I'll be using Excel a lot, not because it's going to be on the test, but because it will be the software that you're going to use a lot, probably, when you have a job. Okay, so if you go to most office work, you would be handling data. If it's not too complicated, usually Excel is enough. And therefore, I want to show you how to use it. So if you look at what I did was, if I wanted to compute something, I put an equal sign in this blank area, and then just write whatever you want to compute. And I want to say, I want to divide this number by 70. And that's how I got this number, 70.3. Is that good? All right. So I'm going to give you some tricks. Later in this course, we will actually take Excel outputs and we have to learn how to interpret the output for, say, linear regression or some other things. But in first exam, I won't be asking how to like do things in Excel, but nonetheless, it's very important that you know how to do these things. Okay. All right. Oh, that reminds me. Before I continue with this, I should have done something extra, which is like, uh, which is how do you get simple random samples? So let's say there's Sam and John and Beth and Ellis. Now, how would you randomly shuffle these things? And assume that this is like a list of employees and you have like hundreds of them. Okay. So let me show you how to randomize. And this is not the only way, but I found it to be quite easy. So if you want to draw a simple random sample by using Excel, this is what you can do. You first say it's equal to rand, open parenthesis, close parenthesis. Now what this does is it gives you a value between 0 to 1. And if you take this rectangle and you see this dot on the right corner, if you put your cursor over it, then there appears the plus sign. And what you want to do is you want to click that and drag it down. And the result is that whatever you put here gets duplicated in the below. Okay. And now what you want to do is, because this is randomly placed, what you can do is you can take the entire thing, select the entire table, go to data, and you can sort using you can sort by the column B. And if you sort it, you see that they changed places, right? Because it got sorted by the values. What's even more interesting is that as it changed, the random values are computed again. So if you sort again, then you can get another shuffle. And you can keep doing this. Right? So that's a nice way to choose random samples from a big group. Okay. So that's what I should have shown you in the first lecture. At the end of the first lecture, I wanted to show you this, but then there were some technical problems, so I couldn't do that. So I finished rather abruptly. But this is what I wanted to show you. All right. So going back, here's our data. We found the average. Now let's go with the median. To get the median, we should first sort this, right? Let's go to the sort. This A to Z just simply sorts from smallest to largest, so you don't have to do anything else, just do A to Z. And now you have all the values. And because there's total of 70, where should we look? 35th. Half of 70 is 35, right? But there's 70 is even. So the exact midpoint is not 35, but halfway between 35 and 36. So what you need to do is you look at the value at the 35th, and you look at the value at 36, and you take the average of the two. What's the average of 70.7 and 70.9? 70.8. Right. So I should be using mean. So mean is 70.3. Median is 70.8. Okay. In this case, they're pretty close, but sometimes they're not. Okay. All right, and then now we have to go for the mode. Okay. For the mode, we have to see how many are repeated, which could be very time consuming. Like I see that these two are repeated, right? It's just too much. So I don't know if there's an Excel function to actually find the mode. I didn't look that up, but I just did the following. There's a if function. If, not this one. I'll start from here. It equals to if the previous one is same as the current value, then I'm going to put 1. And if not, I'm going to put 0 here. Okay. So since they are different, it gives you 0. But now, again, I do that trick of clicking this and dragging it down. So I drag it down. And now you see that you have either 0 or 1. So 1 means these two are the same. So it's easier to see where you get. So here's another one. And if you continue on down, you see that, oh, there's 2 ones right next to each other, which means that you have 3 values that are repeated, right? So 73.2 is repeated 3 times. Now let's see if there's any other occurrence of one just like that. I don't see anything else. So I see that 73.2 is the mode for this data. So mode is 73 point, what was the value? 73.2. Okay. All right. Now let's talk about percentiles. A kth percentile is the data value where it is the element to have roughly k% or more data values to be less than equal to it. Sorry, less than equal to it. I just realized that I should be using the presentation setting. Okay, let's go down. Oh, but I have to go back and forth, so I guess it doesn't matter. All right, so this is the data that we're going to use, but I shouldn't say or more. I don't like that either. So let me change that again. So roughly k% of the data values to be less than equal to it. Now, depending on the textbook, the definition of percentile is slightly different. So sometimes they might not have the equal in the definition. And there's some more complicated definition. Yeah, but we're going to stick with this one, okay? Now, in practice, what does this mean? Well, this is what it means. To calculate the kth percentile, we have to figure out the index number of the data, right? Here, index is like the order that the data appears when you have sorted from least to the highest. Okay, and you calculate the kth percentile by computing the rank as n times k over 100. So what does this mean? Well, it's like if you had 100 data points, then 20th percentile will be 100 times 20 over 100, which is just 20, right? So it's saying that the 20th item is called the 20th percentile, right? Okay. Now, if it is not an integer, you round up to the nearest integer, and it's just important that you round up, okay? So let's do this exercise. Find the 15th percentile of the fire department data, and we will go to the Excel to do that. All right, 15th percentile. How do you do that? Well, again, let's use Excel to calculate. To do calculation, you put equal sign, and there are 70 elements, 70 data points here, times what percentile were we going for? 15, so you do 15 and then you divide by 100. So 15 over 100 is 15%, right? You divide by 100 because this is 15%. If you do this computation, you get 10.5. So what's the index that we were looking for? Yes.
Oh no, this is just for back when you're doing the mode.
Uh-huh.
There's actually a function in Excel. You just put mode and then you highlight the whole section.
Oh, thank you. So Astina just told me there's a function in Excel which has this mode that automatically figures you the mode. Okay. All right. Thank you. Yeah. I'll look into that. Yeah. All right. So, going back, so what's the rank? What's the index number? Huh? What index number are we looking at? We just got this number 10.5. What should we do with this? It's n times k over 100, and then what do you do? You have to round up, okay? You have to round up. So rounding up, you get 11, right? So what? What do you do with the 11? You look at the 11th number. So it's 63, right? So 63 seconds of turnout time for the fire department is the 15th percentile, right? That's what it means. Okay, so the answer to this is 15% of 70 is 10.5. So we look at the 11th element after sorting, which is 63 seconds. Okay. Now, earlier on in the beginning, I said it's important that the 90% percentile should be 80 or below, right? So let's actually change this question now to 90th percentile. Okay, let me give you some time to think about what's the rank number for 90th percentile for this data. Huh? 63, right? So 90% of 70 is 70 times 0.9, which is 63. So we are going to go to the Excel file and look at the 63rd element, and it's exactly 80, right? So that's good, right? So there are cases where the fire department had more than 80 seconds of turnout time, but at least the 90% percentile was 80, so that's good. Okay, so and the 63rd number is 80 seconds. Okay, so in 90% of the time, the fire department responds with 80 seconds or less. All right, now let's talk about quartiles, Q1, Q2, and Q3. The median, which is the element that occurs at the around the 50% percentile, is called Q2. And the lower quartile, I mean, quart means what? Quarter means 25%, right? So lower quartile, median, and the upper quartile, or first quartile, second quartile, and third quartile. These are just simply other names for 25% percentile and 75% percentile. Actually, 25th percentile. I keep making it 75th percentile, 50th percentile. All right. So that's what we have. Now, but because the definition of percentile is slightly different, although percentiles and and quartiles gives you about the same number. Sometimes it's slightly different, and actually for our example, the 50th percentile will be exactly at half, which is 35. So the number that appears at the 35th one would be 70.7. But remember, what was the median? Median was 70.8, right? So there's a slight difference between the two definitions. Now, there's some textbooks that actually have a different, more complicated definition of what a percentile is so that the two will agree. But rather than trying to do that, we will just take another approach where we have a slightly different definition of what Q1, Q2, and Q3 is. Okay. So first of all, Q2 is median. That's it. Okay. There's no question. It's just Q2 is median. That's simple. And to get to the Q1 and Q3, rather than finding the 25th percentile or 75th percentile, we're just going to do the following. Using the median, you divide the entire data into halves. Okay. Yes?
Would you also put it like do like 70 times 25?
Yeah, so your question is, can you just do 70 times 0.25 divide, and then use that, like how we did the percentile, and I'm telling you that that gives you a slightly different value because of the way we're defining what percentile is. Okay, so there's a more complicated way to get the percentile. You can define percentile a little differently, and this is where math and statistics differ a little bit. In pure mathematics, we always have an exact definition, and we always strictly go by that definition. But in statistics, when you come into practical things, sometimes you're interested in one quantity versus the other more. So you would find that there's slight differences in definitions between the textbooks. So we are going to do this approach, okay, for Q2, Q1 and Q3. So Q1 will be the median of the lower half of the data when you divide the entire data into halves using the median. And Q3 will be the median of the upper half of the data. Yes.
So like 35 up is Q1 and 35.
Yes. So in the data that we have, it will be the data from 1 through 35, and the other would be 36 to 70. Okay. Now there are cases when you have odd number of data. In that case, you delete the middle one and you take the Q1 and Q3 separately. Okay. All right. So now let's try to find the Q1 and Q3 from our data. Okay, so for the first half, from 1 through 35, where is the median? So if you divide 35 by 2, what do you get? It's 17.5, right? You round it up, so it's the 18th value, which is 66.6. That's the first quartile, right? Now, if you have, say, like 5, 8, and then 19, 22, 29. If you have some values that's ordered from least to the largest, here's how you get the median if the number's not very big. What you do is you just start matching the smallest and the largest. So this with this, they match, right? And then these two match, and therefore the middle one is 19. That's how you do it. So you can do the same thing for 35 number of data points. I guess it's not too bad. You just have to do this 17 times. And you're going to reach the same conclusion that what you're trying to get is the 18th number. Okay, so 18th number, which is 66.6. Now let's move on to the 36 until 70. And for this, I also need to get 18th number. So let's just count from here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ah, I messed up. Okay, so 1 is 36. So if you so you have to add 18. Okay, so 35 plus 18 is 53. Yeah, 53. So if you start counting, you'll see that 73.6 is the upper quartile. Is that good? All right. So that's going to be the upper quartile. Okay. Okay, now let's move on to frequency tables. What I did was I took that turnout time and put that into bins. So these are called bins, 30 to 39 bin, 40 to 49 bin. They're also called classes. I divided them into bins or classes. So I put them into classes. And I see that in 22 instances of fire, the turnout time was between 60 to 69, and so on and so on. Okay. Yes.
What does that give you? Find the median of Q1 and Q3.
Oh, okay. So if you have, the question was, what does median Q1 and Q3 give you? Well, yeah, thank you for asking me that. So it kind of gives you some feel for the data, like what's like the usual value. A lot of the values are between the lower quartile and upper quartile, right? Especially when your data is like a bell curve. I mean, at least the lower quartile to upper quartile, 50% of the data is there. So you kind of get a feel for what's like a normal data, the usual data values in a data, okay? And I forgot to add here, I should have added here that there's something called interquartile range. And this is upper, it's Q3 minus Q1. Okay, that's called the interquartile range. Okay, so it's a difference between these two. Okay. Now, if this interquartile range is big, then you know that the data is somewhat spread widely. If this is small, then you know that the data is somewhat tight. Okay, so that's another thing that you can figure out. Okay, going back to frequency table. Now, there are some words associated with this frequency table. For each class, say 30 and 39, 40 and 49, these are called lower class limit and upper class limit. Okay, but these are kind of deceptive because it's a common practice to put 30 and 39, then you go to 40. But if you think about it, there are cases where you have response time measured as 39.5. Actually, I think in the data there's one that has like 69.5 in there. Okay. Now, if you have the value of 69.5, where should you put that? Should you put it in here in 60 to the 69 class or 70 to 79 class? 70 through 79, because you have to round to the nearest whole number. And if it's 69.5, you have to round up because it's 0.5. 0.5 gets rounded up, right? If it's 69.4, then it gets rounded down, so it's 69, right? So even if you say that the lower class limit is simply the first number that appears for the range, and then upper class limit is 99, the actual boundaries for these classes are not these numbers, so you have to be careful. The actual boundaries, so the class boundaries, let me see, slideshow from current slide, display settings. Okay, so the class boundaries are from 89.5 to 99.5. So you have to think about this rounding thing, okay? In addition, you cannot have any gaps between, when you go with class boundaries, there cannot be any gaps. So the upper class boundary, not the upper class limit, upper class boundary of the previous class should be exactly the same number as the lower class boundary of the next class, okay? And class width is you just take the difference between the class boundaries, not the class limits, okay? So if you do 99 minus 90, it looks like the class width is 9, but that's not really true. The true width is the value of 99.5 minus 89.5. That's the class width. However, and this is another trouble with statistics, they just come up with their own own way of doing things. So you just have to adjust to what people do commonly. The class midpoint, when you do the class midpoint, you don't get the average of the, I guess you can take the average of these as well. Yeah. Well, okay. Well, class midpoint is computed by taking the average of the lower class limit and the upper class limit. Okay. And I just realized that in fact, you can just take the average of these two and you get the same value, 94.5. Okay. So I guess this last comment, as I said, is not really useful. But anyways, so here's the important parts. Class boundaries are obtained by the average of the lower class limit with the next classes, previous classes of upper class limit. So I'm saying that for this one here, 60, you take the average of 60 and 59, which gives you 59.5. That will be the lower class boundary of this class. You know what I mean? All right. Okay, so that's how you do it. And the class width is the length of class boundaries. And you can also get the same value by just simply subtracting the lower class boundaries between different classes. So you do 70 minus 60, what's that? That's 10, right? So that tells us that the class width of this is 10. To get the class width of here is you do 50 minus 40, so it's 10. So that's another way to get it. And finally, the class midpoint is you take the average of the class limits. And what I wrote here is wrong. It does use the class. You can also do this by taking the average of the class boundaries. All right. All right, and then there's the relative frequency, which is simply taking probabilities, and not probably percentages. So I get this 1.43 simply by dividing 1 by 70. Okay? And then you do 1 by 70, you get 1.43. And if you divide 7 by 70, of course, 7 over 70 is 1/10, right? So that's 10%, and so on and so on. Now, you could also do cumulative relative frequency, which is you not only take the current value, but you add them. So if you have a cumulative relative frequency, at the end of the day, you should be getting 100. Now, this might be important for our case. Yes. Yes. Okay. Are you copying something down? Oh, okay. Okay. Yeah. All right. So you get the relative frequency by dividing the frequency by the total number of data points and write that as percent. And this is also called frequency distribution. And the cumulative relative frequency is also called cumulative frequency distribution. This is actually more used when you talk about the distribution as probabilities. So we're going to be using this word cumulative frequency distribution, or QFD, more. Okay, and then there are these words modal class and median class, which is kind of obvious. In this table, what will be the modal class? What do you think? 70 through 79 will be the modal class because you have the most frequencies. Most of the data is there, right? Now, how would you get the median class? Well, median class is the one that would contain the midpoint between 35 to 36, right? So you're looking for the class which contains the 35th and 36th element in this thing. And if you add 1 plus 1 plus 7, that's 9. 9 plus 22, that's 31. So the 35th element will be where? It should be among these 29 values, right? Don't you agree? Yeah. So again, 70 through 79 will be modal class and median. It will be also the median class. So this is both modal class and median class. For this data, it's true that those two are the same, but it's not always true that the median class and modal class are the same. Yeah. Yes.
So for the median class, where are you like? How are you deciding that factor that's the median, like the 35th like point in that 70
Uh,
grouping?
uh,
How do you determine the median class?
okay. How do you determine the median class? Well, first, add up all the frequencies. That tells you the number of data points, right? And you're going to get 70 because I told you in the beginning. Half of that is what? 35. And because we have an even number of values, the values would be, the median value will be the average between the 35th element and 36th element, right? So the question is, where does that value lie in? Okay. Now, because we had access to the actual raw data, we actually know the median value was what, 70 point something, 70.8, I think. Uh, so I know that it belongs to this class 70 through 79. But you know what happens? A lot of times when you go to some published data, they don't give you the raw data. They just give you this table because it's more convenient to see. So you actually have to count from the least to the maximum. So you have to look at, you have 117, that's 9 elements between 30 through 59, right? And then up till 69, that's 9 plus 22, that's 31. So 31 values when you go from least to the maximum lies before 70 through 79, right? What's the question?
You make your like you find out the median class based on the frequency that you have from this table.
You find the median based on the frequency given in the table. Yes, that's what we're trying to do. So you start adding up numbers and try to figure out where the 35th element fits. And if you do that, you see that it's between 70 through 79. Thank you for the question. It's very good to have discussions like this because other people can see exactly what we're trying to do. Okay. Now, some additional comments. Sometimes one decides on the number of classes before making a frequency table. And in that case, the class width is computed by class width being max minus minimum value, and you divide by the number of classes. So, in our data set, some people might feel that, oh, like we did it by 10 seconds, but I think this is too many classes. Let's say, what if we just wanted like 5 classes? What should we do? Well, in that case, we should go to the raw data and look at the least and the maximum. The least value is 38.7. The maximum value is 96.6. So you do 96.6 minus 38.7. You subtract the 2 and divide it by 5. And you get 11.58. And that will be like your then you round to the nearest number, so it's like 12 will be the class width that you're aiming for. And what you do is you start from, not from 38.7, but you start from 38, right? So it'll be 38, and then add 12, the next one will be 50, and the next one will be 62, add 12 again, 74, add 12, 86, and that should be it. And then it'll be 49 here. So the upper class limit will be 38 to 49, and and to 61 and 73 and 85, and then it's add 11, so it's 97. And you can see that if you do these as your lower class limit and upper class limit and make a table, then all the data will fit, right? And you will have exactly 5 number of classes. So that's something that that could be done. So in that case, the formula to use would be class width equal to maximum value minus minimum value divided by the number of classes. Okay, now some obvious things. What can you do with a frequency table? You can make a histogram. It's a very easy summary, and it gives you some idea of how the data is distributed, okay? And you can also have relative frequency histogram. The difference is it's the same graph as before, but instead of recording the frequency, like the 70 through 79 has 22 occurrences, or was it 20 something occurrences? I forgot. But instead of that, you put percentages. So here you can see that about 42% of the fire incidents, you had the turnout time between 70 through 79. So that's sometimes more informative. You can write relative frequency histogram like that. And sometimes you might have a histogram with cumulative relative frequency overlaid, just like this. And that's, I should actually have another here to say that this is 100%. And this graph actually kind of shows you that, oh, indeed, most, like about 90% of the time, the turnout time was less than 80. So that can be shown. So it's another good graph to be overlaid. Now, there's something about the shape that of a histogram that's important. So let me draw something. So many histograms will look like a bell-shaped curve. And if you have a bell-shaped curve, we say the data is normally distributed. Okay. Now, however, of course, there could be like you can have double M-shaped. If that's the case when you have two kinds of populations mixed together, and there's a lot of the other things. But what I want you to know is that there's something called skewed left and skewed right. So this would be skewed left, and this would be skewed right. Okay. Now that's pretty important, and sometimes also confusing. So this would be skewed left, and this would be skewed right. And it's really about this foot. Okay. So look at the foot. Okay. So you see that the left foot is extended to the left, so that's called skewed left. All right. That will be sometimes asked. So this data that we have is not, it is like bell-shaped. It's not that skewed, but you see that you have more here than the right side. So this would be slightly skewed to the left, okay? But you might have some data that's a lot more skewed. Yes, you have a question? Bell-shaped, you say it's normally distributed. We're going to be talking about this more, okay? All right, last slide. Stem and leaf plot. So what is stem and leaf plot? This is something that's really easy to understand once you understand it. But if it's your first time seeing a stem and leaf plot, then you might be quite confused. So let's go to the end. So here's what you do. This is actually the same exact data, but it's like a sideways histogram. I just made the text too large, so it doesn't look like that. But if you took that histogram and you you rotate it 90 degrees and you wrote it sideways, this is how it's going to look. Do you agree? Yeah. But the stem and leaf plot has added advantage of actually being able to show you what the raw data are. So, for example, this 3 with slash 87 means 38.7 seconds. And 461 means 46.1 seconds. So if you have a stem and leaf plot, you can actually recover the raw data as well as being able to see the distribution. So that's like a very nice way of putting the data. However, uh, any stem and leaf plot must have a legend at the end. I wrote down as legend, but uh, because each stem and leaf and every raw data can be different, you want to make sure that it can be correctly interpreted. So here it says 540 means 54.0 seconds. All right, so last question for today. If you have 8/6, what does that mean? Anyone? 80.6 seconds. Yeah, right. Because it's not 860. If it had 8 comma 60, 8 bar 60, then it would be 86.0 seconds. But it's 8 and 6, and according to this legend, it really means 80.6 seconds. Okay. All right. So makes sense, right? Okay. So hopefully we did.